Okay, now that we have learned how to calculate concentration and moles and volume using our C equals N over V equation, we can start to apply that to our stoichiometry that we learned in our previous unit, so that we can not only do stoichiometry with mass calculations using molar mass, but we can also do stoichiometry with solution quantities, so things that have to do with moles and concentration and volume. So sometimes when you're doing an experiment, you might not know how much mass of something was used to make a solution, like we did with all of our stoichiometry in our previous unit. But what we can do is we can calculate moles based on concentration and volume to be able to then do our ratio and find also moles, concentration, and volume about something, another solution in the reaction. So today's lesson is all about how we can put those two pieces together, what we already know about stoichiometry and how to do these types of calculations, and our solution chemistry. So our 4 steps remain the same. So balance, moles, ratio, convert, BMRC, to answer these questions. So the first step you're always going to do is write out your balanced reaction equation. Our first example that we're going to do together, I've given you the equation, but if you're not given it, you should always write it out first. Okay, then you're going to use what information you are given to find moles of, in this case, we're going to call this A. So A represents the compound that we have known info for. So A here is explained down here. A is the compound with known info from the question. So the question will have to give you some information about at least one thing in the reaction for you to be able to do this, and that's going to be your sort of A compound. Then you're going to do your mole ratio step, so step R, where you're going to convert from moles of A into moles of something else. In this case, we're going to call it B. Now, B is defined here as the compound that the question is asking you to figure something out about. Okay, so this is what the question's asking you to find out. It could be a volume, it could be a mass, or it could be a concentration. Okay, and then our final step, C, for convert. You're going to convert the moles of B that you found in the ratio step to find a quantity of B. Now, quantity, this could be a mass, and you would use molar mass to get there. It could be a volume if you're also given concentration, or it could be concentration if you're given a volume. So quantities here, mass, concentration, or volume. That's what we just defined over there, but it can also be the quantities that you're given at the beginning. So that kind of has to do with the mole step and the convert step, depending on what you're given from the question and what the question is asking you to find. So let's jump into an example, because that's generally the easiest way for us to really see what's going on. So step number 1 is our balanced reaction equation. We already have the balanced reaction equation, so that's great. Let's read the question through carefully. How many grams of zinc chloride will be produced when 1.05 liters of a 2.0 moles per liter hydrochloric acid solution reacts with zinc in the reaction given below? So zinc plus hydrochloric acid gives us zinc chloride and hydrogen gas. Now we can add our state symbols onto here. So zinc metals on their own are solids with the exception of mercury, which would be a liquid. Hydrochloric acid, acids are always aqueous, so we can put that in. Zinc chloride will be aqueous. And hydrogen gas, H2, is part of Hofbrinkel, so it's going to be a diatomic gas, just to have that in there. Now this is already balanced with the 2 in front of our HCl, so that's ready to go. In our question, let's pick apart the pieces that are important that it's telling us. It says how many grams of zinc chloride. So this grams of zinc chloride is telling us that the question is asking us to find the mass in grams of zinc chloride. This is going to be our B substance from sort of the instructions at the top. So that's going to be our B substance. Will be produced when 1.05 liters of a 2.0 moles per liter hydrochloric acid solution. So we're given information about this hydrochloric acid solution. We have a volume. Now it's already in liters, so we can just move on without worrying about that. But if it was in milliliters, we would want to always convert it to liters. And we've got 2.0 moles per liter, so we have a concentration. So C equals 2.0 moles per liter. We can also double check sig figs while we're here. So here 1.05 is 3 significant figures, 2.0 is 2 significant figures. So that means at the end of the question, we're going to want to round to 2 significant figures with our final answer. Now the solution reacts with zinc, so zinc is in excess. We can make note of that if we would like in the reaction given below. So there's our reaction. In this case, we're given the most information about hydrochloric acid. So this is going to be sort of our substance A, and it's asking us to find something out about zinc chloride, which is going to be substance B, if you're following along with the steps at the top. So balanced reaction equation is done. Next step is to convert to moles of A. So we have enough information between volume and concentration to be able to find moles. You can do this in one step. You can do all of them in one, or you can do it in separate steps if you prefer. Just make sure to not round your question until you get to the very end. So here to find moles, remember your magic triangle is C equals N over V. So you can rearrange that to solve for N is going to be C times V, or you can use your unit conversion analysis to find moles that way. So that's what I'm going to do. So here I'm going to start with 1.05 liters of HCl. And I want to convert away from liters and into moles. So liters is the unit here, so I'm going to put that on the bottom, liters of HCl. And I want moles, so moles of HCl is going to go on the top. Moles per liter is the unit, capital M, moles per liter. So 2.0 moles per liter is going to give us 2.0 moles per 1 liter. That's what that number means. So now liters divided by liters will cancel each other out, and we will have found moles, and that will be step number 1. So this is our M step. So our next step is our mole ratio step, where we're going to go from moles of A to moles of B. So moles of HCl are on the top of this conversion factor, so they come down to the bottom, moles HCl. And we're finding moles of B, which is zinc chloride. So moles zinc chloride on the top. This is the step where we use the coefficients from the balanced reaction equation. So in this case, we have a 2 in front of HCl. So we're going to put a 2 with the moles of HCl. And there's no number in front of zinc chloride, which means it's a 1. So we have 1 mole zinc chloride, and that's our balancing step. So here, moles of HCl divided by moles of HCl will cancel each other out. And we're on to our last step. Our last step here is convert into whatever quantity of B the question is asking you to find. So in this question, it says how many grams of zinc chloride. So we're looking for the mass to get to from moles to grams. Moles are here, so moles go on the bottom. Moles zinc chloride. And we want grams, so grams zinc chloride. The number that is in grams per mole is molar mass. So we use molar mass to get from moles to grams. We'll need to do a little side calculation here. So molar mass of zinc chloride is equal to the molar mass of zinc, which is 65.380, plus 2 times the molar mass of chlorine, which is 35.453, is a total of 136.286 grams per mole. So there's our molar mass of zinc chloride. We're going to sub that into our equation. So 136.286 grams per 1 mole. Moles of zinc chloride divided by moles of zinc chloride cancel each other out, which leaves us with the unit of grams of zinc chloride as our final unit, which is what the question asked us to find, so that's good. So now we do all the math in our calculator. You'll take 1.05, you'll multiply it by 2, and then you'll divide it by 2, and then you'll multiply it by 136.286, and that will give you 143.1003. And remember, we have a number with only 2 significant figures in the question, which means that we will need to round to 2 significant figures at the end. In this case, 140 grams of zinc chloride, or you can write it in scientific notation, which would be 1.4 times 10 to the power of 2 grams of zinc chloride, if you prefer to see it that way. Last step always is to write a therefore statement. So therefore, 140 grams of zinc chloride will be produced. Oops. There we go. So there's our whole sort of system for these types of questions. Convert to moles, mole ratio, and then convert to whatever it's asking you for. Check your significant figures and write a therefore statement. We'll do a couple more examples. If you think you don't need to go through any more examples and you want to start working through stuff on your own, then that's great. You can go ahead and do that. But for anybody who would like to see a few more examples, I'll do 2 more examples. So example 2 and 3 in the note. Then there's some homework questions at the bottom for practice. I will post the answers to those and full solutions in case anyone needs to check. So example number 2. Let's read the question through carefully. What mass of precipitate will be formed when excess sodium hydroxide reacts with 85 milliliters of a 0.75 moles per liter solution of copper sulfate? Now, this question is similar to the last one, but it's a little bit more complicated. We have a couple conversions we'll need to do. I'm just going to bring the steps back in to the video so that you can see that all at the same time. In this case, we're not given the balanced reaction equation, so we'll have to do that. We're given milliliters, so we'll need to convert that into liters. And it's asking for the mass of the precipitate. It's not telling us what that is, so we need to figure out which product this is going to be actually asking us about. So the first step is still to write out the balanced reaction equation. So we're going to do that first. Our reagents in this question are sodium hydroxide and copper sulfate. So we'll have NaOH plus CuSO4. Now you might recognize this reaction from our molecular ionic and net ionic equations from the last lesson. So let's go through and give state symbols and figure out what our products are going to be, and then we'll balance it. So sodium hydroxide, anything including a group 1 metal is always going to be aqueous, so that one's aqueous. Copper sulfate, sulfates are usually aqueous. Copper is not an exception to that rule, so it is also going to be aqueous. This is a double displacement reaction, so sodium and copper are going to swap places to form sodium sulfate, Na2SO4. So the 2 from the 2 minus charge on the sulfate is going to come down. Sodium has a charge of 1 plus, so it doesn't get a number there. Again, group 1 metal compounds are always aqueous. Plus copper hydroxide. So here, Cu. Now the charge on copper, we have to figure this out because it could be 1 or it could be 2. In a double displacement reaction, multivalent metals will always have the same charge at the beginning of the reaction and at the end. So if this is copper 2 plus, this will also be copper 2 plus. It won't switch into a different charge. So here, because we know sulfate is a 2 minus charge, the copper must be a 2 plus charge to be able to even it out and have 1 and 1. So that means this copper is also 2 plus. So hydroxide is going to get a little 2 subscript there. And this is going to be a solid. So copper hydroxide is insoluble. It forms a precipitate. So this is our precipitate that we're going to be talking about. So CuOH2, copper 2 sulfate. Now we just need to balance the reaction equation. So 1 copper, 1 copper, 1 sulfate, 1 sulfate, 1 sodium, 2 sodiums. So we put a 2 in front of NaOH, and then that gives us 2 hydroxides and 2 hydroxides. So now it's balanced, it has all of our state symbols, and we figured out what the precipitate is. The question is asking what mass of precipitate will be formed. So it wants us to find the mass in grams of our copper sulfate that we're going to be making. We're given information, it says is formed with excess sodium hydroxide, so we know that this is in excess. We don't need to find limiting reagent. We can do all of our calculations based on copper sulfate, which we're being told is the limiting reagent. Okay, we have 85 milliliters, so here our volume is 85 milliliters. We will need to convert that into liters, so you can do that right away just here, or you can do it as part of the whole sort of reaction. Milliliters to liters, you need to divide by 1,000. So 1,000 milliliters in 1 liter is going to give us 0.085 liters as our volume there. And we're given a concentration. So C equals 0.75 moles per liter. We can also check number of significant figures while we're here. Both of these numbers are 2 significant figures, which means that our answer at the end will need to be rounded to 2 significant figures. So it takes a lot of time to sort of set everything up properly, but it's worth it in the end to take the time to do all of that, and then that makes the rest of the questions so much easier and faster. So now we know we're starting with copper sulfate. This is our compound A. This is what we know stuff about. And we know that we're finding the mass of copper hydroxide, which is our compound B, at the end. So starting with what we know, we need to find moles. So we can start with our volume, 0.085 liters. We want to convert liters into moles, so liters of copper sulfate. So this is CuSO4. CuSO4. Into moles of copper sulfate, so moles CuSO4. Our concentration, moles per liter, that's the unit of concentration, 0.75 moles per liter. So 0.75 moles per 1 liter. Anytime you're given a concentration, the number that you're given always goes beside wherever the mole unit is in your conversion factor, because this capital M means moles per liter, so that's moles per 1 liter, just like how we have grams per mole with our molar mass unit. So now liters divided by liters will cancel out, and we will have found moles. So that's step number 1, is finding moles of A. Now we need to do our mole ratio step. We'll go from moles of copper sulfate, so moles CuSO4, to moles of copper hydroxide, which is our compound B, what we're trying to figure out. So moles copper hydroxide. Our mole ratio here is a 1-to-1 ratio. So you don't have to include this calculation, but you need to make a statement somewhere in a question showing that you know that it's a 1-to-1 ratio and you didn't just forget to do that step. So you either have to write a statement somewhere, then you can skip it, or you need to write it in like this. Moles divided by moles will cancel out. That gives us moles of copper hydroxide. Last step is to convert from moles to whatever quantity it's asking for. So in this case, again, it wants grams. So moles are here, which means the unit of moles go on the bottom, moles of copper hydroxide. And it wants us to find grams of copper hydroxide. To do this, to get from moles to grams, we will need molar mass, so we'll have to do a little side calculation here. Molar mass of copper to hydroxide is equal to the molar mass of copper, which is 63.546, plus we have 2 oxygens, so 2 times 15.999, plus we have 2 hydrogens, So 2 times 1.0079, which equals 97.561 grams per mole. And I've just rounded this to 3 decimal places because when you do addition subtraction, you round to the lowest number of decimal places. Now I'm going to include this over here to convert from my moles, so 97.561 grams per 1 mole. Moles divided by moles cancel out. That's going to leave us with grams. And when we do the calculation, we'll take 0.085 times 0.75 times 1 divided by 1 times 97 is going to give us 6.2195 grams. Remember, we only get to keep 2 significant figures in this question. So 2 sig figs means we're going to round to 6.2 grams of copper 2 hydroxide. Finish it off with a therefore statement. So therefore, 6.2 grams of copper 2 hydroxide will be produced. Just make sure when you write your therefore statement that you are answering the original question. So you might need to reread how it's stated to make sure that you give the correct final statement. Okay, so now we've done 2 examples. This one was very similar to the last one in that we started with volume and concentration and we were looking for grams at the end. This one we just had a couple extra steps in it with the conversion of milliliters to liters and the writing out of the balanced reaction equation. Our next and final example is a little bit different because it's going to be about 2 solutions and we're not going to be calculating anything with a precipitate. So moving on to example number 3. What volume of 0.150 moles per liter hydrochloric acid is needed to neutralize a 25.0 milliliter solution of 1.35 moles per liter sodium hydroxide? So this is a neutralization reaction, which is a special type of double displacement reaction. Again, let's start by writing out our reaction equation. We're given information about our 2 reagents. We don't know anything about the products, but we'll figure that out next. So we know we've got HCl plus NaOH. Now HCl is an acid, hydrochloric acid. It's going to be aqueous. Acids and bases are always aqueous. Sodium hydroxide, also aqueous. We know that from our last question. Group 1 metals are always aqueous. It's a base, bases are aqueous. Double displacement reaction, our hydrogen and our sodium are going to switch places. That's going to give us NaCl plus, you can write this as HOH because we're taking this H and this OH, or you can write it as H2O. It's the same thing. That's fine. Sometimes it's helpful for people to see it in this form, which is why I write it like that, but you can write it as H2O as well. So H2O is a pure liquid, so we're going to put an L there as its state symbol. Sodium chloride is aqueous. Group 1 metal plus chlorides are usually aqueous as well. Now we need to just double check that it's balanced. Hydrogen, we have 2 hydrogens on this side, we have 2 on that side. 1 oxygen, 1 oxygen, 1 chlorine, 1 chlorine, 1 sodium, and 1 sodium. So it's already balanced. We have all of our state symbols. Our next step is to organize all the information given to us in the question in a way that helps us answer it. So I like to write everything out underneath sort of all the little pieces. It says what volume of this concentration of HCl is needed. So we're given information that the concentration of the hydrochloric acid is 0.150 moles per liter, and it's asking us what volume we are going to need. So that's going to be our final thing that we're looking for. To neutralize 25 milliliters of a 0.135 moles per liter sodium hydroxide solution. So here we're given concentration of 0.135 moles per liter of our sodium hydroxide, and we're also given volume, so 25.0 milliliters. Now again, we need to always convert our volumes into liters. So we may as well do that quickly first. 25 milliliters divided by 1,000 milliliters to make 1 liter is going to give us 0.0250 liters. Now make sure you don't lose that significant figure. Even though it won't make a difference in your calculations, you need to know that that number has 3 significant figures, not 2. Because if we look at all the numbers we're given in the questions, this one has 3 significant figures, this one has 3, and this one has 3. So we know that they all have 3 significant figures, and our final answer will be rounded to 3 significant figures. So now that we've organized all of our information, we can start to work through the other steps. So this is our balance step. Our next step is to find moles of whatever we know the most about. We know the most about sodium hydroxide. We have concentration and volume, just like we've had for the last 2 examples, which means that we can find moles of sodium hydroxide. We start with our volume, 0.0250 liters of NaOH. We want to convert that into moles, so liters on the bottom, moles on the top. Our number that's in moles per liter is concentration, moles per liter. So here our concentration we can use to convert liters to moles, 0.135 moles per 1 liter. Liters divided by liters will cancel out, and that gives us moles. Our next step is our mole ratio step. In this case, it's a 1-to-1 ratio between our sodium hydroxide and our hydrochloric acid. So again, you can write this as a whole step, which is what I will do, or you can make a statement saying that it's a 1-to-1 ratio, so you don't need to actually do any math. Either way is fine, as long as you don't just omit the whole step. So moles of NaOH are here, so I'm going to put moles NaOH on the bottom. And I'm wanting to find information about the hydrochloric acid, so moles HCl on the top, 1-to-1 ratio, so 1 and 1. But now moles divided by moles of sodium hydroxide will cancel each other out. Final step is to convert what we want to know in moles to liters. It asks us to find volume. Now we can use concentration, which is in moles per liter, as a conversion factor. If you prefer, you can do sort of an equals here. You can find the number of moles and then use your magic triangle, or you can do unit analysis, which is what I will do. So here we have moles of HCl. So moles of HCl go on the bottom. I want liters, so liters of HCl will go on the top. And you'll notice that this is moles per liter, just how this is moles per liter. It's just that we've flipped it like we did with our molar mass in grams. But this time our concentration, 0.150, is going to go on the bottom. So 0.150 moles per 1 liter. Now moles divided by moles will cancel out, and we'll be left in a volume in liters of our HCl. So now we're going to do the math. We'll take 0.025, multiply it by 0.135 times 1 divided by 1, then divide by 1.50. And that's going to give us 0.0225 liters of HCl. We have to round that number to 3 significant figures, just like we talked about at the beginning, because all of these numbers are 3 significant figures. And that is going to give us 0.0225 liters of HCl. Now in this question, it didn't specify what unit the volume needed to be in, so we could end things here, but often in chemistry, we want to convert our volumes back into milliliters, because in the lab, we measure volumes mostly in milliliters, and especially because this number is quite a small number for liters, we can convert that into milliliters to make it a little bit more useful. So 0.0225 liters times 1 liter, so liter to liter on the bottom, multiply it by 1,000 to get to milliliters on the top. That's going to give us 22.5 milliliters of HCl. So final statement then. Is going to be, therefore, 22.5 milliliters of 0.150 moles per liter HCl solution will be needed to neutralize the given NaOH. Awesome. So I know that was a lot, and there's a lot of practice questions to do. We'll talk about that a bit more in our class, but feel free to send me a message if you have questions, and I will make sure that the solutions for the homework questions are also posted so you can check your answers if you get stuck. All right, see you guys later.